This is our part 1 class on evolution of AI. This is part of the entire series AI techniques from simple neural network to GenAI model. The agenda of this entire series is looking at AI evolution from ancient logic to deep learning. We also will learn GenAI evolution from early models to cutting edge innovations. We also look at how generative AI model works and applications of generative AI models and how to implement GenAI models and what are all the risks and limitations associated with GenAI model and its implementation. And also we will look at how to build an responsible GenAI model and how to improve GenAI performance. Finally, we will look at what is AGI, which is artificial general intelligence. So, now we look at AI evolution from ancient logic to deep learning. So, when I say artificial intelligence, just think about it when this artificial intelligence concept started. So, even before the term AI was coined, artificial intelligence was coined, the history goes back to very long time back, which is around 380 years BC. During that time, Aristotle founded the formal logic and syllogistic reasoning. He was the one came up with a novel idea how the human thinking process can be universalized and interference can be automated. Then in 1943, researchers McCulloch and Pitts, they studied the biological neuron and they came up with the mathematical model of the biological neuron. And in 1958, the perceptron neuron came up. The researcher Frank Rosenblatt, he modified the McCulloch-Pitts neuron and made an advancement in the neural network. So, this is the foundation for the entire advanced AI models what we are seeing now. Then around 1970, one student from Finland, he came up with a novel idea of backpropagation algorithm, and he mentioned about his algorithm in his master degree thesis. But sometime later, during 1986, the backpropagation algorithm was developed by Jeffrey Hinton and fellow researchers specifically for AI model. That made the breakthrough in the AI advancements. Whatever we see is based on backpropagation algorithm. All AI models starts from single layer perceptron to the deep network, and GenAI models are based on these two different concepts, perceptron concept and backpropagation algorithm. And first we will look at the Aristotle time. During 384 years or around 322 years BC, Aristotle had his own contribution to human reasoning, and syllogism is he documented the first principle of inference, that is drawing a conclusion from a set of premise. Look at this premise. So, premise 1 says all men are mortal, and premise 2 is Socrates is a man. So, there are two statements. Can you come up with a conclusion or inference from these two statements? What Aristotle said is, when a human being were given with these two premises, we can come up with an inference. The inference can be Socrates is mortal. Since all men are mortal, Socrates is a man, and the conclusion is Socrates is mortal. This is human reasoning. Can we automate this human reasoning? Yes, human reasoning in this perspective can be automated, and machine can replace this simple human reasoning. So, this was documented by Aristotle during 380 years BC back. And let us look into next mathematical model of biological neuron. McCulloch and Pitts, they studied how the biological neuron works and how we can come up with a mathematical model of our biological neuron. So, before going to this concept of mathematical model of biological neuron, uh, do you all know that how that human species live? We all know that without brain we cannot live. So, brain is a central CPU of the human organism. That in our human brain there are 86 around, an average human being has around 86 billions of neurons. So, can we imagine how complex our human brain networks is? It's completely clueless, and it's very difficult to understand how the entire human brain works. It's interconnection of around 86 billions of neuron interconnected, and what it does, it receives information from all our sensory organs, and then it processes the information and reacts to that information. It gives an output, or it gives an instruction to other parts of our human body. And we will look into how a single neuron works in our human brain. So, this is how the human brain looks like. Basically, it consists of three different parts. One is the head, which is called as dendrites. Dendrites is a tree-like structure. This tree-like structure is the one which receives information from nearby neuron through the junction called as synapses. The synapses connections passes the information from the nearby neurons into this dendrites. So, the dendrites passes that electrical signal into the next component, which is called as cell body. The cell body is basically a nucleus which has its stable potential, which is little bit negative potential, which has around minus 70 millivolts. So, when it receives electrical stimulus through the dendrites, then the cell body, which aggregates all the electrical stimulus, and sometimes it crosses some threshold. If it crosses a threshold of around minus 50 millivolt, then this resting potential will activate the cell body, and it creates action potential. This action potential, sometimes what it does is it opens up some kind of gates in the cell body and allows to some chemical components flow inside the cell body. I am not an expert on neurology, so I do not know how the entire brain works, or the single neuron works, and the simple the mechanisms lives in this within a single neuron is somehow it receives some chemical information, and it exceeds its resting potential, and it creates an action potential. This action potential is actually propagating the electrical signal through the third component is called as axon. This axon propagates that electrical signal that received from this second component, and it's sent to the nearby neurons through this axon. So, this is how the biological neuron works. So, I do not know the complete mechanism, that complete chemical reaction on all other complex actions involved in a single neuron. This is simplest way that I can look at and perceive the electrical signal in terms of electrical signal. There will be beyond lot of things. We do not know that, even I do not know that how the electrical signals and the chemical compounds possesses that information or knowledge, how it is being stored by these kind of electrical signals and chemical components, that I do not know. But this researchers, they looked at this biological neuron, and they came up with a mathematical model. They got inspired by how neuron works and came up with mathematical model. In this mathematical neuron, there is a cell body. The cell body receives information from input vector, which is input data. Here it is called as x1 to xn, and when it receives the information, and there is a connection strength, which is summation by the connection strength, and this is the aggregated information Z. And when this aggregated information value is crossing the threshold value T, then this cell body, the mechanical cell body fires through axon and outputs an information of 1. When it fires, it outputs 1. When it is not greater than the threshold unit T, then it does not fire, that means the output becomes 0. So, this is a simplified concept of mechanical neuron. So, this artificial neuron receives information which is actually in binary units, the information x1 to xn or either 0 or 1, then cell body aggregates the information and then outputs the value y prime. The y prime is also binary, either 0 or 1. So, with this simple mathematical model, the researchers were able to stimulate simple logical gates like AND or other gates. Then we will move into the next model, which is perceptron model. So, the researcher Frank Rosenblatt, he came up with this perceptron model in 1957. So, the perceptron model proved to be a highly effective and laid the groundwork for advancement in AI. So, we will see how this perceptron model looks like. The left side is the McCulloch-Pitts neuron. Here the input informations are binary units and the output information is also binary unit. But in perceptron model, this is just a mathematical model. So, why do not we relax that condition that input have only the inputs have only the binary values. Instead, if we allow the input vector to be continuous one, and also we allow here cell body that aggregates information and then produces the output value. Then output value is a linear equation where bias value is also added B, and then it is a kind of, when you look at this equation, which is actually a linear regression equation, then there is an action potential applied on, then after applying that activating function, the output is A. Here in the output is also can be a continuous value or can be a binary value. So, with this mechanism, see how beautifully it works. That neuron aggregates this information and it puts one bias value, and activation function is applied on and it outputs a value. We will see the applications, how this perceptron is used in different types of networks, neural networks. First, we will look at single layer perceptron model, and single layer perceptron model has one input layer and one output layer. Usually, the input layer is not considered as a neural network layer, because there is no computation happens inside this input layer. Only the computations and activation, everything happens in output layer, and you see there is a connectivity between input layer and output layer. This connection strength is very important in predicting the output accurately. The perceptron models are capable of learning from the data and identify patterns from the data, and also used to classify or predict something. So, this model learns to predict or classify very accurately. How it does, how that mechanism of prediction or classification happens, it is basically based on the connectivity strength. Connectivity strengths tell how important the each input information is while processing the output value. So, let me look at an analogy. So, I am running an detective agency where I am a primary detective agent. My job is to assign the entire detective job to my workers. So, in this analogy, let us assume that I have 4 workers. Assign that detective job these to 4 workers, and 4 workers goes to various places and collecting the information from from various sources and coming back and giving it to me. the input in that information. Then my duty is to aggregate all those informations provided by those 4 agents and come up with an prediction, my prediction. So while I am doing so, the first agent could be very knowledgeable or very experienced and very hardworking. He might be giving more accurate information. So what I would do is, I give highest importance to the information provided by the first agent. The second agent might be hardworking, may not be very smarter like the first one. So I give little less priority to the second one. Maybe the last agent might be very lazy, not hardworking, not knowledgeable. Sometimes he gives some kind of false information or some kind of irrelevant information. So I should give very least importance or no importance to the final input, the final agent. So what I would do is, I aggregate all the information, I gives different various level of importance to different information, so that my prediction would be accurate. So if I rely on the last agent, my prediction becomes false. So what I would do is give equal, not instead of giving equal importance, I prioritize the information and gives based on their accuracy and importance. The same way here, the connection strength gives assign importance to each information. If the information is very important in predicting the outcome, the connection strength, weight vector, that is called as weight value. Weight value will be very high, otherwise it would be low. So the weight value tells how important that information is. Using the single layer perceptron, we can model a problem that can do simple prediction and classification. And look at that multi-layer perceptron. In multi-layer perceptron, there is an in between another layer called a hidden layer. There is input layer, hidden layer, and output layer. At hidden layer, that same function happens, aggregation as well as activation. Then it passes that abstract information learned from the hidden layer into output layer. For the output layer, the input is coming from hidden layer. So what is happening here by adding hidden layer? So any nonlinear information can be analyzed or categorized using this multi-layer perceptron. There is a universal learning rule. What that universal learning rule in AI domain says that if I have one hidden layer, with this one hidden layer, I can approximate any complex function, any complex continuous function, I can approximate with the neural network model. This is the power of neural network. Using even single hidden layer, I can approximate any complex function using finite number of hidden units. This is the power of neural network. So the neural network can approximate any function, any complex function in the world. So we will stop here. We'll continue in our next class. Thank you for watching our video.